Okay, students, the topic for discussion is stack. In this topic, we will study how a stack is dealt in 8085 microprocessor. Basically, stack is a data structure which works on the principle of LIFO, last in first out. Whatever data will be inserted last will be fetched first. So, and why the stack is used? Stack is used for various purpose in a microprocessor. Basically, it provides programmer a temporary storage of information. In 8085, stack grows backward into memory. Backward means from higher address to the lower addresses. So, to implement the stack, programmer defines the bottom of the stack and stack grows up into the reducing address range. Reducing address range means from higher order addresses to the lower order addresses. So in 8085, the stack is defined by the setting stack pointer. As we all know, the stack pointer is a register which points the top element of the stack. And because 8085 implements the stack from which grows backward into the memory, so stack pointer is always loaded with the address FFFF, because this is the highest address in the memory used in 8085 microprocessor. So whenever we implement a stack into 8085 microprocessor, we will load this address with the help of LXI, load extended immediate SP pointer. So this command will load this address into stack pointer. Now stack pointer will point this location, and the size of stack is always limited by the available memory. The stack will grow up to the available memory. Stack is accessed with the help of two instructions. One is push, second is pop. Push instruction is used to insert any element into the stack, and pop instruction is used to fetch any element from the stack. So push or pop, the process of inserting any element into the stack is called pushing, and fetching out any element from the stack is called popping. And here it is very important point that a push or pop instruction will work with the register pairs B, C, D, E, H, L, and so on. So let's have a look on push instruction implementation. So suppose SP is pointing this location FFFF. Now we have to insert the element of the content of register pair BC. How it will work? First, SP pointer will be decremented. So from this point, SP will point to this location FFFE, and the element of register B will be copied here. For the next element, the SP pointer will also decremented. So now the location pointed by the SP will be FFFD. and at this location the content of C will be copied. So recently stack pointer will point to this location because this is the top of the stack. Here always push instruction will work with the register pair, and pop similarly it will work with the register pair and it will fetch the element from the stack. So first, if we want to pop the elements of a stack, so top element will be fetched to some register. Suppose we are using here DE pair of register. So first element will be copied to the register E, then stack pointer will be incremented. So now stack pointer will point to the location FFFE. Next, the element of this location will be copied to the register D and then stack will be incremented. Stack pointer will be incremented. So now the stack pointer will point to the location FFFF. Whenever we input the element into the stack pointer will decrement and then we will copy the elements of a register. Whenever pop instruction will be used, first we take the element out of the stack and then increment the stack pointer. So the stack can be used to store the data as well as PSW, which is program status word. So we can have the data into stack or we can have status information into stack. So in similar way, if we want to store the program status word into the stack, it will also work in pair. So whenever we insert the program status word into the stack, we will work with register accumulator and flag register. Flag contains the program status word and accumulator will contain the result of operation. So similarly, as push instruction work, here the same process will be used to insert the program status word into the stack. Similarly, first we will decrement the pointer, stack pointer, then we will copy the register content, A register content into stack, then we will decrement the SP pointer and we will copy the content of flag register. So if we have inserted the program status word into the stack, now we can take program status word out of stack. So this will work similarly pop instruction. Same accumulator and flag register will work in pair. So first we will take the top element of stack into the flag register, then we will increment the stack pointer. Next the stack pointer will point to this location and we will take the content of a stack into accumulator register and then we will again increment the stack pointer. So this is the process to take program status word out of stack. So both the process are similar to pop the data from stack and to pop up the program status word from the stack, but the content, or we can say the data, is different. So this is all about the stack implementation of 8085. So importantly here, the stack works on LIFO structure, last in first out, and it grows backward into the memory. It will this is if it is the start from a 0000 address to FFFF address, so uh, it will start from higher addresses to the lower addresses. Next two instructions are used, push and pop, and both the instructions work with the register pair. Register pair content will be inserted with the help of push instruction, and we can take the content of topmost two topmost elements of stack with the help of pop instruction. The data can be we can simply insert the data into the stack, or we can simply insert the program status word into the stack. Okay, thank you.